Hi, we're group number 33, and for our final project, we did rendering caustics underwater. So in order to do this, we used photon mapping, which is an extension of ray tracing, in order to render realistic caustics that were caused by light refraction. And we built this on top of the Project 3.2 code, and we focused on using the Blender to generate DAA files and also creating the photon maps. So caustics were hard to implement, but they were essential for making the caustics and the scenes look realistic. So if you see here, you can see that the second picture, which is our final product, looks much more realistic than the beginning because it actually takes into account for like the caustics. And here are two of our favorite scenes. And the second one has like a round caustic, and that's because the ripples on top were rounded.
And here you can see a little animation of the water level rising, and you can use that to see how the caustics change over time. And then we're moving on to the technical approach. And so to make good looking caustics, you have to have good looking water. And to represent our water, we applied a refractive glass-like material to our water representation with the appropriate IOR. And then to make it actually have waves and stuff, we used displacement mapping on the top part of the water surface.
Now for photon mapping. This is an efficient global illumination method, and it runs in two phases. The first is generating photon maps, which is done by starting at a light source and shooting out photons into the scene. Their interactions are stored in two different photon maps, one for global illumination and the other for caustics. In the second phase, we use regular path tracing combined with the information in the photon map to estimate the radiance at different points in the scene and then render those out.
We learned some interesting things about the photon map. For example, as you can see in the animation, when we increase the number of photons, you can see that the caustics get sharper. Similarly, when we decrease the radius used in the radiance estimate, the caustics also get sharper, but the image gets noisier. Some important lessons that we learned in this project were the importance of visual debugging tools, especially when it comes to computer graphics projects. We also learned the importance of focusing on the program input and not just the code itself, because sometimes the input is correct and the input is incorrect and the code is correct. In general, photon mapping is an effective method for rendering caustics, not just underwater, but with any scene with specular surfaces.